Greetings and welcome. Welcome and greetings. We're talking about systems of equations and word problems related to them. So I'm going to teach you some word problem skills here. We typically follow the VESA model, which is you write your variables, you write your equations, you solve those equations, and then you write your answer in terms of the context of the problem. Because if someone asks me, which baseball hat they should buy, and I just say, X equals 20. Like, they were like, what are you talking about? Like, what? That's not what I asked. Like, I don't even know what X is, right? So you want to communicate effectively, translate it from math back into the English. So let's see. The school that Lisa, by the way, Lisa, my mother's name is L-I-I. Let's see. Those are terrible. L-I-I-S-A. Double I Lisa, because she's from Finland. And she works with someone who's Lisa with a single I in their name, so they call them Lisa with two I's and Lisa with one I. And so whenever she refers to Lisa with one I, it sounds like she's just being really cruel to someone with some sort of, deficiency. But really, she's only just I deficient, like she's lacking a vowel is all it is, not an organ, so that's fine. But anyways, that's a side note. There you go. Enjoy. So let's see. So the school Lisa goes to is selling tickets to the annual talent show. Let's see, on the first day, ticket sales, the school sold blah, 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 blah. Now, I'm going to write my variables. And actually, typically, you can kind of skip over most of the problem and just figure out what is the question. It says, what is the price each one of the senior citizen ticket and one of the student tickets cost, right? Blah, blah, blah. So they're interested in price of senior citizen tickets and student tickets. So that's going to be my variables. So I'm going to say X equals price of senior citizen tickets. And that price is going to be measured in dollars, right? We're not going to harvest those senior citizens for their organs and make them pay us that way. So dollars is probably a better currency. And as a school fundraiser, it's probably better that way. Unless they're like trying to harvest things for their science class that they could then, perform some sort of dissections on later. I don't know. So anyways, price of student tickets, I'll just call it ST, will be Y, also measured in dollars. And so labeling your variables is important because I might have assumed that if you just wrote X equals senior citizen, are you talking about the number of senior citizens in the school, or the number of senior citizen tickets sold, the price of those senior citizen tickets, the width of a senior citizen ticket? I don't know. Like, what is X? So you got to be specific. And that's actually going to help you later on in writing our equations. So let's, for our equations, we decipher our facts. It says on the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. So, what fact can I write there? What would equal $102? 4x plus 5y, perfect, right? So this term right here, 4 senior citizen tickets times the price of the senior citizen ticket should give me the amount that we got from the senior citizens, and this is the amount we got from the students. Add those amounts together, $102. Easy enough translation. Next fact, the school took in $126 the second day by selling 7 senior citizen tickets at X dollars a piece and 5 student tickets at Y dollars a piece. Okay, so there we go. So if I want to solve this now, I think I've gathered all the facts. I don't think some of these were important, like the talent show aspect didn't matter to us. But in solving, now I've got a system of equations, and I'm going to solve by elimination, I think. I'm going to multiply this top one by -1. Why do you think I wanted to multiply the top one by -1, not the bottom? Yeah, I was just looking at like this number compared to this number, and I figured, subtracting the smaller one would be nice, and this number compared to this number, subtracting the smaller one would be nice. So that's my only reason. The dollars actually would have come out positive in the end, even if I didn't do that. So it would have all been fine, because I would have had a negative divided by a negative in the end. Negative 4x minus 5y equals negative 102. and then I'm going to add them up, and I'll have 3x equals 24. And then div it up. And we'd solve from here. Let's see, blah, 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 blah. X equals 8. And then, of course, I can solve for y by plugging this into anything that I want to. I'm going to plug it into the first equation because they're smaller numbers in general. And typically, I'm looking for the easy way out. Mathematicians are efficiently lazy people, right? So let's see, this would be 32 plus 5y equals 10 dos. Hundo doso. Man, oh, that would be such an awesome nickname. Let's see, 5y equals 70. Divide by 5, divide by 5. Oh, let's see. Now check this math out that I do in my head. 70 divided by 5, I don't know what that is, but what's 70 divided by 10? 7, and then double it, because 5 would fit in twice as many times. 14. Bam. How cool is that? Right? Good math right there. And now I can answer the question. And what's my answer? Oh, x is 8, y is 14? No, that's not an answer, right?
So do we have complete sentences?
Yeah, and look at these sentences write themselves. X is 8. So I could just literally like piecemeal this in here and say 8 is the price of senior citizen tickets in dollars, if you wanted like a super formulaic way to write it. So, so senior citizen tickets cost $8. And then student tickets cost $14. Not bad. Bam. Done. Answered. Right? So not that bad. So the key to the breakdown is first figure out what your variables are. Those are found in the question often. And then decipher those facts into equations, some sort of constraints that we can then solve and optimize. So let's see. Here's the next problem. Flying with the wind. Wow. So here's going to be my little airplane. So here's an airplane. It's flying with the wind, so the wind is going whoosh, 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 right, with it, right? And it flies 183 kilometers an hour. 183 kmhs, right? And then flying into the same wind, so maybe on the trip back, I imagine, oh, wow, this plane's really going crazy now. I don't know what happened. The wind is like, whoosh, like blowing it up, like, and it's going, like tail spinning or whatever. So, yeah, here's a little tail on it there, I guess. There we go. So, flying against the wind, or into the wind, it's only traveling 141 kilometers per hour. All right? So it says find, all right, oh, these sound like variables. Find the speed of the plane in still air. That sounds like a variable name, all right? X is speed of the plane in still air. And what would that be measured in, do you think? Yeah, that's probably better than light years per eon. So kilometers per hour. Probably because, I mean, I don't want to have to convert these. They're already in that, so that makes sense. And let's see, then it says the other variable is the speed of the wind. And that would also be in kilometers per hour. Bam. So now my equations, this one seems like it should be complicated because you see some rates and you immediately think rate times time equals distance and all this other stuff, but it's actually easier. I know their combined rate, and I know what variables represent their individual rates. So the speed with the wind, how could I translate this first sentence into an equation for us? What components went into this? What caused the plane to move that fast? The wind, so the wind speed was part of it. And then what else affected the plane's overall speed that day? Right, and I could probably just add those together, right? And that would equal the total speed. Does that make sense, right? The plane's speed in still air plus the speed of the wind equals its actual speed, right? So this one's, it seems like it should be more complicated because you saw like these rates, and you want to make it fancier than that. Let's see, so what about the other fact, when the plane's working against the wind? What would we have going on here? Yeah, the plane speed minus the speed of the wind equals 141, right? Good stuff. And then we could solve from there and answer the question. But I think for sake of time, I think you guys are experts at solving, really. And it looks like this is pretty good at just eliminating the y's. Yeah. So I'll have what? 2x equals 324. So x equals 150, 162, is it? I'm guessing. And then to find y, you can just plug that in. So 183 minus 162, y ends up being 11, is it? Did I get that right? You guys agree? So we end up with our sentences, the speed of the plane, is 162 kmhs, and the wind is 11 kmhs. All right. So I mean, the solving part you guys are all experts at. It's the V and the E that's going to be challenging for us in this lesson. So do your best on this. I think we're going to be great. Happy times. Bye-bye, internet friends.